All right, this is APAB Calc. We're doing the Intro to BC Calc unit. This is topic number 2, which is integration with partial fractions. So in example 4, we have a definite integral. So now we suddenly have bounds. Again, just as a reminder, this could be u sub if the so if the numerator were a multiple of the derivative of the bottom. So the bottom is x squared plus 8x plus 15. So if you were to derive that, you'd get 2x plus 8. So if the top were some multiple of 2x plus 8, right, like 2x plus 8 or x plus 4 or 20x plus 80 or something like that, then this could be u sub, but it's not, and that's kind of the hint that it's partial fractions, right? You don't want to disregard u sub as an option because it is still an option that happens. Like, there are definitely times that it comes up, but most of the time it doesn't. So I'm going to make the same suggestion I've been making, which is that it makes the most sense to separate this and do your work on the partial fraction decomposition first. So partial fraction decomposition first. So I have this negative 2x minus 2 on top of, when I factor this, I get an x plus 3, x plus 5, right? So that means I have two linear factors. I'm going to get an a over an x plus 3 plus a b over an x plus 5. So really my task here is to find a and b. So you're going to get a common denominator that is identical to this denominator, meaning a is going to get times by the x plus 5 over x plus 5, and b is going to get times by the x plus 3 over x plus 3. So if I just want to skip to the step where all I'm looking at is numerators, nobody thinks that's cheating, right? As long as you do it properly. So you're going to get negative 2x minus 2 equals a times the quantity x plus 5 plus b times the quantity, that's a b, x plus 3. All right, I'm then going to use my clever substitution. I'm going to start with x equals negative 5. That's going to knock out the a term, right? So I'm going to get a positive 10 minus 2 equals b times a negative 2. So I think I get 8 equals negative 2b, so my b must be a negative 4, right? And then for the other term, to knock that out, I'm going to plug in an x equals negative 3. And when I do that, I'm going to get 6 minus 2 equals a times a regular 2, right? So I get 4 equals 2a, so a must be 2. So the trick here is that really the only hard part is the non-calc, right? The pre-calc is most of the work. So if we slide this back over here, sorry, that was an aggressive slide, I'm going to get the integral from negative 2 to 1 of my a, which is 2 over x plus 3, with respect to x, plus the integral from negative 2 to 1 of my b, which was negative 4 over an x plus 5 dx. Now, you don't have to split them apart into two integrals. If you were going to use u substitution, you would have to, because your u's would be different. They would be u equals x plus 3, and u would be x plus 5. I say if, not because this question doesn't require u sub, but because since it's a simple form of u sub, you can kind of skip it. If your u were the bottom, u is x plus 3, then your du is just dx. So essentially, this is going to be a 2 over u, meaning you're going to get 2 natural log of the absolute value of u. The same thing's true here. So if I want, I could kind of keep them together and just do the u sub in my head and get that this is 2 natural log of the quantity x plus 3 minus 4 natural log of the absolute value of the quantity x plus 5, and I'm evaluating from negative 2 to 1, right? So when I plug in, I'm going to get that this is a 2 natural log of, when I plug in 1, I'll get a 4, minus a 4 natural log of 6, right? Sorry, I just noticed that I added wrong on the answers. Yeah, minus a 2 natural log of the absolute value of 1, and then minus a negative, so it'll be plus 4 natural log of an absolute value of 3, right? So I get 2 natural log of 4 minus 4 natural log of 6. Natural log of 1 is 0, so it's gone, so I get plus 4 natural log of 3, and that right there would be my answer. Now, on the answer sheet, which I will fix at some point, this is accidentally a 5. I wrote natural log of 5 when I meant natural log of 6, because apparently I can't add 1 and 5 together correctly and get 6. So, mea culpa. Cool beans?